Today we're going to talk about functions and their inverses, section 9.5. So continuing on talking about functions, now today we're going to talk about what makes their inverses. Inverse functions. Not all relations are functions, and not all relations have inverse functions. To decide whether the inverse of a relation is a function, use the horizontal line test. Now, horizontal line test. We have actually already used the vertical line test. Remember vertical line test?
A little bit.
We use vertical line test to determine whether a graph is a function or not. Okay, so for example here, a vertical, wrong one there. Vertical line test here, if it ever touches that vertical line twice at one point, it is not a function. Okay, we use the vertical line test. Today what we're going to talk about is the horizontal line test. To determine whether a function has an inverse, you use the horizontal line test. So if you look here, it touches it only 1 point, so it would have an inverse. So that'd be a yes. This one over here, it touches that graph 1, 2, and 3 times, so that means the inverse would not be a function. Okay, and that's all it's saying. Alright, so if any horizontal line passes through more than 1 point on the graph of a relation, the inverse of the relation is not a function. Any spot. Any spot on there. Well, you want to run your horizontal line all the way through it and check it. Don't just check it right there, because right there it's good. But you want to make sure the whole graph satisfies it. Okay? So using that information, let's look at numbers 1, 2, 3, and 4. Use the horizontal line test to determine whether the inverse of each relation is a function. As I come across, I can draw a horizontal line. Would that relation have an inverse? Would the inverse have be a function? No, it would not. It meets right there and there. It meets at 2 points. What about number 2? Would that relation have an inverse? Or would the inverse be a function? Yeah, if I look at all these right there, that one would. If I look here at this coordinate at 1, at x equals 1, at y equals 0, what are those places called? Those are called what? Who remembers?
What places?
Starts with A? Asymptotes. Those are asymptotes. That's where the line's going to come as close as it can, but it's not going to touch there. Number 3. Would number 3's inverse satisfy a function?
Yes. Yeah.
And what about number 4? Would number 4 satisfy? No. Okay, so again, horizontal line test can be used to determine whether the inverse is a function. The inverse of a function, fx, is denoted by f prime x. So that is like this. That means the inverse. To find the inverse of a function f of x, write y equals f of x. Hopefully we all recall that y, or f of x, is just fancy for y. Okay. So to find the inverse, you are literally and figuratively going to just switch x and y. So you write y equals f of x, so substitute y in, and you switch y and x, and then solve the equation for y. So for instance here, I take my equation, y equals x squared minus 1, and I switch x and y. So it becomes x equals y squared minus 1. And then I solve for y. So notice to solve for y, you add 1 to both sides, take the square root, and I get y equals plus or minus the square root of x plus 1. And that is the inverse of that function.
So you have to keep the square on the sides already on? Is that what you're saying? Do you?
Yes.
Okay.
Yep. So don't take the x squared with it. Leave it. Because y could have 2 different values of x, for example, the positive square root of x plus 1 and the negative square root of x plus 1, this inverse is not a function. This one would not be a function. You can check by graphing the original function on a graphing calculator and use the horizontal line test. Now, you can use a graphing calculator, however, I'm going to show you how to do it mentally. For example, let's say I have just an x term. We've talked about types like parent graphs and basic graphs. What type of graph does just x get us? Anybody? Like a line. A lot of you right ideas. It's just a basic line graph. Would a basic line graph pass the horizontal line test? Okay, so good. What about x squared? What type of graph does that get us? What's that called? A parabola. Would a parabola pass a horizontal line test? No. So again, recognize that if I have an x squared term, the inverse would not be a function. Remember that. I have not seen x cubed on here. Square root of x. What type of graph does the square root of x get us? Something like that, right? It's kind of like a half shape. It's like a half a parabola. Okay. Would that pass a horizontal line test?
Yeah.
Yes, it would. Trying to think what else we had. A plus or minus the square root of x is a sideways parabola. Okay. So that one, notice that, plus or minus. All right. And again, just having that understanding of what the basic graph would be can tell you whether the inverse would have a function or not without having to graph it. So for instance, our original problem here, f of x equals x squared minus 1. What type of graph would that get us? That would get us a parabola. Well, I don't need to graph that. Would the inverse be a function? No, because it would not pass the horizontal line test. So just kind of look at what that basic graph is. Domain and range. What does domain represent? Domain represents my, and range represents my. Awesome. Now, the domain of the inverse is the range of f of x. The range of the inverse is the domain of f of x. What that means here is when I flip x and y to find the inverse, the domain and range also flip. It's the same thing. So don't have to double your work and find everything twice. Find it from the original problem, flip it, change it, you're fine. Let's look at number 5 here. Find the inverse of each function. State whether the inverse is a function. F of x equals 2x minus 6. A says to substitute y for x. Why do we do that? Because f of x is fancy for y. So I get y equals 2x minus 6. Part B says switch x and y. So I switch them. X equals 2y minus 6. Now I solve for y. Well, how would I solve for y here? I have x equals 2y minus 6. What would I need to do first to solve for y? Add 6. So I get x plus 6 equals 2y. And then I would divide by 2. Now I get y equals x plus 6 all over 2. Or I could say y equals 1/2 x plus 3. Does everybody see why I get the 1/2 x plus 3? When I had the x plus 6 all over 2, I just divided each part by 2. So 6 divided by 2 is 3. 1x divided by 2 is 1/2 x. So that is my inverse.
Why would you have to switch the y back?
What?
Why would you have to move the y back?
Just always write as y equals. I just always like writing y equals first. I mean, you're just flipping it around. It says to graph the original function using a graphic calculator is the inverse of function. Well, we don't have to graph it. Let's look at it. What type of graph would this get us? This would get us a line graph. Would a line graph pass the horizontal line test?
Good.
Is the inverse a function then?
Yes.
Yes, it is. Nice job. Let's look at number 6. Find the inverse of each function. State whether the inverse is a function. Number 6. F of x equals the square root of x plus 3. F of x is fancy for y. So y equals the square root of x plus 3. Notice I switched x and y. So I now have x equals the square root of y plus 3. Now I need to solve for y. What would I do first? What did you say? I would subtract 3. Nice job. So I subtract 3, getting me x minus 3 equals the square root of y. What undoes a square root? A square term. So I square them both. Cancels, and I end up with y equals x minus 3 squared. Now, what is x minus 3 squared if we were to work it out? It is not x squared minus 9. Because what does it mean to be squared? It means you take it times its cell. So really x minus 3 squared means x minus 3 times x minus 3, which means now I need to FOIL. First outer inner last. X squared minus 6x plus 9. Now, let's come back to the original problem here. F of x equals the square root of x plus 3. What type of graph does the square root function get us?
Sideways.
Sideways like that. Would that pass a horizontal line test?
Yes.
So would my inverse pass the horizontal line test? Or vertical line test? Yes, it would. This is a function. Number 7. F of x equals 2x plus 1. F of x is fancy for what, Marisol? Y. So I have y equals 2x plus 1. What do I need to do next here, Kelly? So I have x equals 2y plus 1. Now I need to solve for y. What would I do first to solve for y, Jersey?
Switch it over.
We just did that.
Subtract 1.
So I subtract 1. I get x minus 1 equals 2y. And then I would do what, Shanks? Divide by 2. And I get y equals x minus 1 over 2. Or you could say y equals 1/2 x minus 1/2. Both those are acceptable answers. Now let's go back to the original problem here. What type of graph does f of x equals 2x plus 1 give me? That would be a line. Would a line pass the horizontal line test?
Yes.
Is the inverse a function?
Yes.
Yes, it is. Nice job.
What do you?
Take a couple seconds to try numbers 7 and 8. Find the inverse of each function. State whether the inverse is a function.
How do you have 2?
Try these two. Number 7. P of x equals x squared plus 1. What is the inverse of this function going to be, Miss Tech? Nice job. Number 8. What is the inverse of number 8? Inverse of number 8 would be what, Jesse?
2x plus 2.
Y equals 2x plus 2. Now let's go answer the question. State whether the inverse is a function. Now let's look at number 7. What type of graph would number 7 originally get us? That'd get us a
Like a
parabola. Would the parabola pass a horizontal line test?
Ow.
So there is not an inverse.
What happened?
Let's look at number 8. What type of graph is number 8? That is a...
Line thingy.
Would that pass the horizontal line test? Yes, it would. Now, one last thing here. 7. Let's talk about domain and range. What does domain represent? Domain is my x values. Can I put any x value in there? So when you're checking these, always check extremes. Like, can I put 0 in there?
Yeah.
Can I put positive 1 in there?
Yeah.
Can I put negative 1 in there? Can I put positive 100 in there?
Yes.
Could I put negative 100 in there?
Yeah.
Okay, so I could probably put in all x values, right? So my domain here is all real numbers.
So if it's square root, domain's always all real numbers.
Just wait. My range now. If I put in all real numbers, what happens when I put in, let's say, 0? What do I get? 1, right? If I put in a positive 100, do I get something back out? A lot of that. Higher than that, probably. I'm talking about, I'm talking about like the original problem right here. I'm talking about the original problem. Can I put a negative 100 there in the original problem? Yes, because negative 100 gets me like, what's that, 10,000 plus 1? Okay. Do I get all y values back out here? I do not. Because what type of parabola do I have? My parabola is going up here, right? Wouldn't I have a minimum value here somewhere?
Yeah.
My minimum value here is actually at y is greater than or equal to 1. My range is y is greater than or equal to 1. Does everybody see why it's 1 here? Take a guess. Because it's x squared plus 1. Okay, so my range here is y is greater than or equal to 1. Now, domain and range of my inverse is just flipped. So domain of my inverse is what? Take a guess. Well, it's x is greater than or equal to 1. Because what's the highest value I can, or lowest value I can put in there? 1. What's my range then? Take a guess. My range would be all real numbers. Okay? The domain and range of these are just flipped, just like you flip your x and your y. As I look at number 8, what's my domain of number 8? Anybody? Domain of number 8 would be?
2.
My domain. Can I put any x value in there?
Yes.
So my domain is all real numbers. What's my range then? Would I get any real number back out? It is a line function. I get any number back out. So my range is all real numbers. So what's the domain and range of my inverse then?
All real numbers and all.
All real numbers and all real numbers. It's going to be the same thing. Exactly. Here's your assignment.